Hi everyone. We're here with vBrownbag US. We had to reschedule, but we're here 10:30 Friday morning, talking about Google Cloud Platform, specifically Kubernetes, with Brian Dorsey. And I'm your host, Lauren Malhoit at Malhoit. Just a few quick notes before we get started. You can follow us on Twitter at vBrownbag or at vBrownbag Latam, at vBrownbag EMEA, at vBrownbag Junior. So all sorts of places on Twitter. If you have any questions or anything like that, feel free to mention them on Twitter using the hashtag vBrownbag. Or if you're, of course, attending this, you could always raise your hand and ask a question within GoToMeeting. Watch our other shows, APAC region every other Thursday at 10 p.m., EMEA every Tuesday at 7 p.m. Latin America, we have Thursdays at 7 p.m., and of course, US is usually scheduled every Wednesday night at 7:30 p.m. Central. Um, as I said, our guest today is Brian Dorsey. Brian, how are you doing?
Good. Thanks
Uh,
for having me.
of course. And with that, I will pass things along to you and
Okie doke.
let you be more interesting than me.
Let's see. Okay, show my screen. Here we go. Um, can you, in fact, see my screen?
You're good on my end.
Excellent. Okay, so thank you, everyone, for taking the time to hear some things about containers. We're going to talk about containers, Docker, Kubernetes, and what it basically give you an overview of why we think containers are important, and what Kubernetes is, and hopefully give you a teaser of why this is worth looking into. So let's head right into it. So big picture, why? Like, why do we care about all of this stuff at all? And the promise here, and the reason I think it's worth learning these new concepts, right? Because there's a lot to learn. Kind of looking at Docker and the container set of abstractions, and then there's some more abstractions for Kubernetes. And basically, the promise here is that you get to spend more time focusing on your application, building the features that your users see, and making the world a better place, right? Your application gets better faster. You spend less time operating it, managing it, scaling it, and honestly just kind of reasoning about the shape of it, that sort of thing. So it's the core thing. Help you focus on the most important parts of your application. As a little bit of context setting, so we're going to there's a lot of different places you could run software, right? So of course, you can do things like Google App Engine or Heroku. This might be like platforms as service stuff. So the general idea here is you write some code. You probably have to write it to match the environment a little bit, especially for App Engine. And then you push that code up, and then we run it for you. We scale it, all that sort of stuff. Everything works out great. On the kind of other end of the spectrum, like what I imagine folks from vBrownbag are very familiar with, you've got virtual machines, right? So you've got a computer that can run whatever operating system you like, and then you can run whatever software you like on top of that. And you are responsible for everything from the operating system on up. So what we're going to talk about today is taking a whole set of machines or virtual machines and thinking of them as one logical computer, right? So you've got this whole cluster, tens, hundreds, thousands of computers, and you want to think about them as one computing unit, and really, actually think about your application running on these things. So that's where we're going to focus today. So before we kind of kick into that, containers are what really let us do this. And I imagine there's folks listening from all kind of backgrounds. So if you know this stuff, awesome. And if this is a little bit new, I'm going to try to give enough context to make sense of Kubernetes and containers. And a little bit kind of, where we're coming from. Like, this is a scenario that I think all of us are familiar with, right? So you've got a computer somewhere, and you install an application and all of the libraries and dependencies it has to run. and then you install another application, and then another application. And the reason we run multiple applications is just for straight up efficiency, right? So your computer's a certain size. Most of the time, most of our applications aren't using the full machine. If you do, it's kind of easy actually, right? You just runs at 100% proc, 100% network all the time, and you just dedicate that machine to that work. But most of the time, these things ebb and flow, or the apps are smaller, and so you run a lot of different things on the same computer. And I've definitely gotten into the situation where the dependencies are tricky enough. So like all the different applications running on the machine. So I go to upgrade my program, and there's another program on there that needs a different version of things, or has some dependency that I didn't expect, and I've broken somebody else's app, or a different another app that I'm responsible for. And you get to the point where you're like, oh, that server is a little special. We don't want to touch that one anymore. Every time we touch it, something else breaks. So like I fear that machine. So that's the situation we don't want to be in. Virtual machines really help us with, right? Because one of the things you can do is you can have an execution environment for each application, and you can give that application as much of the host machine as you want, or as little as you want. They have their own environment. You can keep the libraries and dependencies separate. If one of them choose 100% proc, the other ones aren't affected. But it is pretty heavyweight, right? So like in this example, we actually now have 5 operating systems we're responsible for. And at a minimum, they use a certain amount of memory. You have to keep them up to date, keep them secure, and that sort of thing. And this can definitely work. But it can also be a challenge to recreate these environments on, say, dev or test, or on laptops, because they do use a lot of resources. And containers, you can kind of think of them in some ways as best of both worlds. So, you can, because they are just processes, but they are constrained so that they can only see certain parts of the file system, the image that they're based off of. We have this isolation in terms of their dependencies. They're not seeing each other. The way we create them, they have process isolation as well, so that they could only use a certain amount of process, CPU, memory, network, and it's kind of best of both worlds. So Google loves containers. We've been basically every service that you've interacted with that Google runs is running in a container. So this is things like Gmail or search. If you've read papers about MapReduce, it's all of these things, and that makes sense, right? Batch jobs. But even things like our distributed file systems, like GFS, and our data stores, we run those in containers. And in fact, even our virtual machines, Compute Engine, run in containers. So we love containers. And I'm going to run through some of the reasons for that. One, just straight up performance. Like these are processes. They're Linux processes, so they just start very, very quickly. You basically set up a little bit of network and disk, and then start the process. So you're looking at millisecond kind of startup times.
Hey, Brian.
Yes.
On that last slide, you said even VMs run in containers. Is that right?
Yes. Yeah. So even
what's the reason for that?
So our data centers, we're set up so that we have this uniform set of for efficiency reasons, right? So in our data centers, you might have a production Gmail job right next to an intern's Hello World app as they're learning the infrastructure, and they run at different priorities, but they can all be on the exact same machines and all running together. So the way software runs in our data centers is on containers. So even our virtual machine software ends up running in this environment.
Yeah, that's awesome.
Yeah, it gets a little funky. The turtles all the way down at some point, but yes, they're running in containers. And so perf is one aspect there. And thank you for asking, by the way. Do more interactive stuff as we go. Repeatability is another big thing with containers. So I'm not really diving into the details, but every every process you start is based on this template, this image template. So you've got an image that you've built, and it has a certain file system inside. And every time you start a container from that, it basically starts from the exact same starting state on disk. So when you, every time you start one of these, it has the same starting state. So like if you're running it in test, dev, prod, it'll run the same way. You do get to set these quality of service constraints I talked about. So like, you can say this, this process is only allowed to use, half a processor and 100 megabytes of memory. And so, if it goes crazy, it can't go beyond that. And this is what allows us to run, these production jobs right next to like an experimental job on the same machines. Because these are all in containers, we can treat everything the same. All right, so like, and this is kind of the promise of the container, metaphor of the shipping container, right? Everything's running in a container, so it doesn't matter what language it's written in or which tools it uses or whatever. We can treat them all as one unit. It's them all the same, and this allows us to do things like collect metrics and logs in the exact same way across all the different processes. So that's super useful, and you can also then know which part of the company is responsible for which things, how much of the data center you're using, how much of your cluster you're using, and because they're the containers, the images, you're bringing the image along with you, so you're bringing the file system along with you. You can run these in lots of different environments, and so in our world, like I can run a container on my laptop, I can run it on Google Cloud, I can run it on AWS, I can run it on machines that I own, and it works the same way wherever I run it. So it's a bunch of nice things we get from containers.
So when
It
you
does
when
mean
you talk
that
about
you end up with this.
oh, sorry. So when you're talking about portability and you
Go
can
ahead.
actually move, can you hear me?
Mm-hmm.
Okay. You can actually move a container from like a server to your laptop. To do that with a VM, it's totally possible, but can be a little time intensive, I guess.
Yep.
What's the process with that on a container? Is it easier, would you say?
So the like straight up live migration, there's definitely people working on that. Google doesn't really do live migration of containers, where you've got like a process that's running and you capture its state and kind of serialize it somehow and move it over and kind of reconstitute it. What we do is we just start a new one based on the same image and turn off the old one. So in this level of portability, what we're saying is we can start the same process that does the exact same thing in a new place, and it's going to run the same way. And our whole, and this kind of hits at this different mindset as well a little bit. So we treat these containers as very ephemeral. They come and go. We're not attached to any particular one, and what state you have, kind of needs to live outside the containers. So you've got databases or groups of containers that work together to store the state.
Gotcha.
So in the portability I'm talking here is less kind of live migration and more
Cloning.
we'll make new ones. Cloning.
Okay.
Exactly.
Cool.
And this hits at how this is kind of a different so that aspect of it, and also we build these images that and we kind of imply this. A lot of people talking about containers kind of imply this, but often the image, the template for the container, is something that comes out at the output of a build system. So you can just make them, from a developer machine, but often you've got a build system, and you kind of like, you grab all the jars you need and like run some process, and an image comes out, or you've got a Python app and you collect all the dependencies, run your tests, make sure it all works, and you output this file system image. So this gives you this early binding for your app instead of a normal deployment, I'll call it late binding. So basically, when are you going to find out that you're missing the dependency, that the app doesn't work, or there's a different version of things out there, what have you. This forces all of that kind of up to happen early, and you find out about things early, and then once you've got an image that you've tested and works right, you can then run the exact same environment out, which is really, really nice. Um, so in some ways, it's analogous to, kind of statically typed versus dynamically typed languages, although I'm a big dynamic language fan. Um, okay, so at this point, we're going to assume that we are all convinced and that containers are awesome, and we're going to run lots and lots of containers everywhere. And if we've got, so let's say we do this, right? And then we're going to try to map a fairly simple application that I think everyone will be familiar with the architecture. You've got a PHP app, running Apache perhaps, that talks to a database, a relational database, MySQL, and also talks to an in-memory cache. So key value store, memcache, to look at stuff. And if we're gonna run each of these pieces in containers and kind of push them out across a cluster of machines, we do still have kind of a lot of things to worry about. And many of these are true even if we're not in containers. It's like, so which host does this run on? How do the different pieces find each other? Like, how does the PHP know where the cache is actually running right now? How do we make sure that they're healthy and that they stay running? What if a whole host machine actually falls over and crashes? How do we scale when we get a lot of load, or how do we scale it back down when things are not busy? And then I think this one is especially telling. When you have an environment you're happy with, how do you test that? Like, can you recreate that same environment in QA or for your developers to work on? And this is where Kubernetes comes in. It comes from the Greek word helmsman, so I'll kind of switch here to Kubernetes. So I had a Greek person pronounce this for me, and as I understand it, the Greek word is pronounced something like Kubernetes, but this is a software project from the West Coast of the United States, and so we say Kubernetes. So you just kind of, Americanize things. So Kubernetes, and it is an orchestration system for containers. So you have, basically you'll take a set of machines and install Kubernetes on it, and then you can treat them all as one execution environment. And it runs Docker containers. It can also run Rocket containers, and we've recently announced working with many other people in the container space, working towards a standard that everyone can use. So that stuff's going on. It is an open source project, so it's been up on GitHub for about a year now. If you want to see Google engineers code reviewing each other and other folks from the open source community and see all of the long conversations that happen there, this is a great place to do that. So like all the issues are live, and this is a realigning it open source project. And it runs in multiple environments, so you can, of course, it runs well on Google Cloud, but it also runs on AWS, it runs on Azure, you can run it on your own machines. It is, in some ways, like an installation layer. So if you kind of set up your app and configure it so it can run in Kubernetes, you can set up Kubernetes clusters in lots of different environments and run them. And this is a new system. It's definitely inspired by and informed by Google's experience running containers internally. And you may have seen we released a paper recently on Borg, the system we call Borg, that runs our containers internally. So many of the same engineers are actually working on Kubernetes from Borg, and a lot of the lessons learned are part of Kubernetes. So in some ways, it's actually better than Borg, and in other ways, it's it's a new project, so it lags behind in some areas.
Hey Brian, I don't know
Yep.
if you know the answer to this, but could you also run it on things like white box network switches and things like that?
So could you run it on network switches?
Yeah, like
themselves?
like white box, if bare metal kind of switches.
So you can run it on bare metal computers,
Hmm.
but you basically need a Linux kernel
Hmm.
to run Kubernetes. So if you've got a Linux kernel, in principle, that can run Docker, in principle, and you can run processes, you should be able to run Kubernetes.
Okay.
Most of the time, though, people are running it on, just kind of regular computers, or most people are actually running it on virtual machines in a cloud provider of some kind.
Sure, sure. Yeah, sorry. Sorry. Um, coming in from the networking world, that we do run a lot of Linux containers. So I guess I don't know why Kubernetes wouldn't, right?
Awesome. Yeah. So actually, that's an area that I'm not super familiar with,
Hmm.
of the network infrastructure actually running containers. That
Sure.
is something I would like to hear more about. That sounds awesome. Um, okay. So yeah. So this is open source. It's written in Go, and the goal here is really to help you focus on your applications, not which particular machine they're running on, and like is that one busy, and where do I put this process, and when I want to run more, that sort of thing. So you get to kind of think about your app, and in fact you configure Kubernetes at the level that looks kind of like a whiteboard diagram of your app. So you know like, oh, I have these front end pieces, and um, you know in this scenario, like you actually are reasoning about things in terms of like I've got a PHP portion, a MySQL portion, a Memcache portion, that sort of thing. And the the key concept there, when you're doing this configuration, is you are focusing on how you want the world to look. So you might say, I want to have 5 copies of my PHP front end running. And so you send this configuration off to Kubernetes, and it's then Kubernetes' job to make sure things stay that way. If one of the processes crashes, it should start a new one somewhere else. If one of the host machines, one of the nodes, crashes, they should reschedule all the containers that were on that, somewhere else in the cluster. Um, and so, you know, you basically, this is one of the things that gets you paid less often. Um, instead of having a kind of a set of steps, where most, kind of management tools and orchestration tools kind of have a set of steps that they're following. Okay, I want to to do a deployment, I do A, B, C, D, E, F. But if it has trouble partway through, that's a real challenge. Um, and if something unexpected happens, it's not able to adapt. And so Kubernetes very much focuses on you tell it how you want the world to look. It runs a loop to see whether the world currently looks the way you want it to look, and then does whatever changes need to happen to make it look like that. Um, so um, to kind of think about mapping your application to Kubernetes, I think there's 4 concepts that you need to know. There's a few others that are fun, but these are the 4 that you really need to know to think about how to kind of arrange your pieces to work in Kubernetes. And so these are pods, replication controllers, services, Kubernetes services, and labels. And a pod, is the unit of scheduling. It's basically a container. Can be more than one, but it's very often just one container. And these are what we actually schedule. So you might have 5 pods that are each on 5 different hosts that are your front end pods, for example. And then you have a replication controller to keep track of those, and a service to help you find them, and they might have labels to help you disambiguate them from other things running on the cluster. So let's dive into each of these.
Hey, Brian, we have a
Yep,
question real quick from Twitter. Is
absolutely.
Kubernetes idempotent?
Idempotent. Um, in terms of configuration,
When it
yes.
reruns, I guess.
Okay. So the containers themselves, are every time you start a container, it's starting from the same state. So each one's going to start up fresh. The configuration, I want to have 5 of these running. You can run that configuration. You can send that to the API multiple times, and it will it'll work the first time, and then it'll know that you already have that named there the second time and not allow it to happen. In terms of like whether or not you can rerun the same things without having side effects, like idempotency, I think I may be misunderstanding the question a little bit. So I'm going to leave it there. Maybe if they clarify and you see that, grab me again. Um, so we've got these four concepts, and let's dive into a pod. So a pod is one or more containers. And we added this extra layer because we believe containers should be very focused on doing one thing. Usually that means running one process inside of them. Uh, and and this allows you to kind of mix and match your containers, to compose them so that they can work together. So many times you will actually just have one container. It might be in our example, it might be the PHP, the Apache process that listens on port 80 and runs your PHP. And each of these pods runs on one host, one node in Kubernetes, and it has its own IP address. So unlike running straight Docker containers where each container is kind of behind a NAT layer, we give every pod an IP address in the cluster space, and every pod can see all of the other IPs directly if you need to. Pods are considered ephemeral, so they come and go. Kubernetes will schedule them as it needs to. And if you do run multiple containers in the same pod, they share the IP address, and they can talk to each other over localhost, over name pipes, that sort of thing. An example of where you might want to do that is if you have a static site generator that maybe pulls from Git or some database, and generates HTML, and it writes that HTML out to a local volume that the pod has access to, and then you decide to serve that up. So maybe you use a standard web server, Apache, Nginx, what have you. So you can combine the web server with your custom static site generator. They can both see the same file system, and then you kind of create this unit of work that's there. So that's a pretty common pattern. The replication controller is what implements, is one of the main things that implements one of these loops that allows Kubernetes to focus on this desired state. So this is what's actually, when I say I want to run 5 pods, I'm actually telling a replication controller I want to run 5 pods. And then it looks and see how many are running and starts or stops them. So you could think about this as a process supervisor, but for kind of the whole cluster. So an example of how this might play out. So if we have a replication controller, the cubes here are nodes, they're computers, VMs. The little rectangles, blue rectangles in here are pods that may have a couple of containers in them. And we've told the replication controller we want to have 4 of these running in our cluster, and we have 4 of them, so it's happy. And disaster strikes. And we lose a node, or we lose kind of access to the node, perhaps, maybe it's just over the network. Kubernetes notices that there's only 3 of our pods running and starts another one somewhere else in the cluster. Later, if this node returns, it'll notice that there's actually 5 of them running, and it'll stop one of them from the cluster somewhere. So it's just kind of always running in this loop to make sure we have the right amount of pods running. And the next concept is services. So a service it's basically just a load balancer, but it's a load balancer that knows where the pods actually are in the cluster, which ones are healthy, and it gives us service discovery because it gives us a stable named endpoint for each of our things. So, for example, we might have a service around the cache service, around memcache. And so then we can just connect to that over a DNS name, memcache, or over the stable IP. And wherever that gets scheduled in the cluster, like whichever node it's on, we don't care. We can always connect to it directly at this IP and port. So this is the key abstraction for simplifying. Once we have many containers running in a cluster, this helps us focus on part of the system that's stable, and the pods can come and go, and Kubernetes has flexibility to run those wherever it needs to, and you have stable, kind of easy to reason about endpoints for your apps to talk, the different parts of your apps to talk to each other. And then how do containers and replication controllers find the pods? How do they know which pods they're responsible for? That's labels. And labels they're basically just key value pairs. They're, and in this case, we've got a cluster here with, 5 pods in it, and we have just picked our own keys and values. So we decided to apply app to all of them. We've got one of them that's app encoding, the rest are all app guestbook, and then we can kind of run queries against the cluster and see, okay, which of our pods are part of the guestbook app, and which of them are actually, let's just look at just the front end pods, or just the back end pods, or just the ones that are in a development group or in test. And so this lets us kind of slice and dice and make sense of our cluster as a whole. And labels are the only grouping mechanism in Kubernetes. So when you want to, set up a group of processes, of pods, labels are how we do that. And everything in Kubernetes actually can have labels. So the replication controllers have labels, the services, pods, everything. So if we take this architecture that our kind of very, very simple app, what this would look like in Kubernetes is we've got a pod running MySQL behind a service, pod running Memcache behind a service, and then we have this dotted line as a replication controller running multiple different pods running our PHP app. So I think we should see this. And now we get into the nearly live, or live for some of us, demo, but it's still just as risky because it's a live demo, no matter whether you're watching this live or later. So we'll see how this works. So I have here just a little command line and in 2 windows, and in the bottom I have kube control, which is our command line tool, running in a loop 3 times to show me the status of a cluster. And the cluster is running over here on Google Cloud. So I have, if we kind of scroll down here to container clusters, I have a cluster called vBrownbag. It's made up of 5 nodes that are each 2-core machines. And we can go and poke at this and kind of see what's running. So I have started a few things. So I started the actual Memcache and the MySQL. So cooking show wise, we're kind of partway in, and then we're gonna start the front end, and then connect to it and see what we have. So I actually have services set up for each of these, and so if I grab this public IP address for the service and I try to connect to this guy, we should get, oh hey, look at that. We should get this error from the proxy server at the hotel that I'm at, which basically says, yeah, there's nothing running at that IP address. So let's fix that. So in our current directory here, we have, so you configure Kubernetes via, we've got YAML or JSON files, and then you kind of send those off to the API server. So if we take a look at this front-end service configuration, for example, it starts off just which API version, it's a service. We give it some labels. So here's our key value pairs about this thing. And then the service is basically saying, I want to expose port 80 TCP and create an external load balancer. True. So that's what gives it a public IP address outside the Google project so that we can actually hit it from the web browser. And we are going to make all of the pods that map name front end and app next demo available over this service. So I've actually run that already. And then we've got a replication controller config. And this is what sets up a template for creating a new pod. So we've got kind of similar labels. And then we're going to say we want to run 2 replicas. We're going to use this same selector to find them. And this is the template for making new pods. Basically, we're going to give them labels every time we make them. And importantly, we're going to base it off of this Docker image and give it this name, and it needs to listen on port 80 internally. So this is a reference to the Google Container Registry, which is basically just a Docker registry that is implemented on our blob store, Google Cloud Storage. So when you're running stuff in Google Cloud, it makes sense to put things here because it's very close and very fast, very reliable. And then this is just a straight Docker container or Docker image up on that registry that's called PHP Guestbook with a specific version. So we can use kube control to create a new replication controller from this file front end RC. So we run this, and down here this is refreshing all the time. So very quickly we actually have 2 new containers that are out and scheduled, and they're getting ready, and can actually start receiving traffic soon. So in theory, I should be able to come over here and refresh this, and hey, we have an app. And so any of the live folks who notice that IP can join our guestbook and be nice. So we can actually kind of push this in, and we've got a guestbook. It's legit, right? So I'm going to go ahead and run this plugin that will refresh this page every second. So this page will now be refreshing in the background every second as we do things for the rest of the time here. So so if this guestbook gets incredibly popular, our application gets more and more traffic, we can run kube control here and scale the replication controller and called front end, and we want to set replicas to 6, for example. And then, so we've now changed our configuration, told Kubernetes we want to run 6 instead of 2, and it immediately, schedules those new pods and puts them somewhere in the cluster, and they start running. And you can see in the background our app is still chugging away. It's still running. Every time we refresh, we get the live application. It's working, and that's lovely. Or we can kind of scale it back down later, and the same thing. And some of those pods will get shut down, and we can use the resources for other things. So that's super cool. But this is kind of a boring guestbook, and we can probably improve the design a little bit. So we've actually got another image. So this is the image that's currently running there. We've got another image, and I'm going to actually copy this so that I type it correctly. And we are going to use this command called rolling update. And I'll just run this right now. And it's going to, right. Do, do, do. Proof that it's live. What am I doing wrong? Let's try to type this by hand. Kube control, we're going to rolling update the front end. I'm going to set the update period to 2 seconds. And we're going to use, and so this is just for demo purposes. Normally you would have a much longer number there, and that's just how long we're going to go between pieces here. And then I'll grab this from here. And we'll see what we get. Nope. So I have something wrong in my demo, and I apologize.
Did you mean to have quotes around that image? Doesn't matter.
In this case, I don't have them, and I didn't think I needed them.
Just because above you had them, I was just...
Yeah, I added those in there.
I know way less than you do.
No, I have something wrong in my example here, so um, I apologize. It's probably something I'm doing dumb on the command line, or um, like. So I'll just talk through kind of what this would do. Or actually, this is where we have our video. So when I did this before, we've got this guy, went through these things, we scaled, and now we're going to rolling up update. Um, and so we do this rolling update. And what this is doing, so we had before, we had a single replication controller running a certain version of these pods. So rolling update, it starts a second replication controller and starts rolling out a new version of the app. So we've got two replication controllers, and we kind of have two big knobs here where we can say we want to run, more and then less of each of these versions. And so it rolls through bit by bit and pushes out more copies of our new green background version and gives us fewer copies of our previous version. And so as you can see here, the whole time the app is up, and then at some point, users start getting the new version of the Guestbook. And that's awesome. So we've done an update of software running in production without taking things down. Yay. The amazing thing here, in my mind, is that reverting to a previous version of the application is actually exactly the same process. So an upgrade and a downgrade are identical. You get to you just push out a different version of the thing, and then you're good to go. So and this is towards a large degree what we get from containers, right? Because we're pushing out the image with all the dependencies every time we do this, and this basically gives us this identical process to go back and forth. So that is the demo there, and that brings us kind of to the end of the kind of prepared presentation. So thank you very much. And I don't know if there were any questions live or more things from Twitter or things you wanted to ask about.
I think we're good all around. I'm just double checking Twitter. Just to prove it was live, I did put a little message on your
Awesome.
guest book
Thank you.
there.
Yep.
So
It's legit.
that's really cool. It is. It's legit. But yeah, that's awesome. And what a great presentation too, Brian. Thank you so much for doing that. And to those who could attend, thanks for attending. Any final thoughts, Brian, or are you all set?
So I would like to just say this is an open source project. Please take a look at it. Kubernetes is very quickly approaching 1.0, so it's going to hit 1.0 in a couple of weeks at OSCON. So by the time you kind of see this podcast, or webinar, it may already be 1.0 and ready to go. Please give it a try, play with it. We're very, very active on IRC and of course on GitHub. So please join us, run your stuff, see how things work. It'll be fun to play with things.
Cool. And will you be at OSCON?
Will be, yes.
All right, that's in Portland at the end of July, right?
Yes, it is.
All right, very cool. I think vBrownbag, at least some contingency from vBrownbag will be there as well. So hopefully we'll capture some
Fantastic.
good videos there. Yeah. All right. Well, with that, thanks to everyone for listening, and we'll see you next time.
Excellent. See you all.